Welcome back. This is Investigation 4.4, Finding Expected Value. Today's focus question: how is expected value different from probabilities of outcomes? Let's find out. Okay, part A. Suppose Nishi has a 60% free throw percentage and is in a one-on-one free throw situation 100 times during the season. Number one, how many times can she expect to score 0 points? We would expect that to be 40 times, because 40% of the time she would score 0. How many times can she expect to score 1 point? What is the total number of points for these situations? So we'd expect 24 times, and it's 1 point, so it would happen 24 times and 24 points. And number three, how many times can she expect to score 2 points? That would be 36 times. And it's 2 points, so it would be 72 points. Number four, what total number of points do you expect Nishi to score in these 100 situations at the free throw line? So 72 and 24 is 96 points we would expect her to score. All right, so if we know it's 96 points, 5 is asking the average number of points for a one-on-one situation. So 96 out of 100 attempts, 96 points in 100 attempts would be 0.96 points per trip to the free throw line. Okay, and then number 6 is use the data you collected from the spinner simulation in the last problem. Calculate the average score for the experimental results of Nishi. Okay, so if the theoretical is 0.96, my results, I put them back up as a reminder. So you'll have to look at yours, but it was 30% at 0, 25, and 45%. So we would think 30 out of the 100 times would be 0 points, 25 out of the 100 would be 1 point, so that's 25 points, and then 45 times out of 100 would be 2 points, so that's 90. It's 115, which means that the average score would be 1.15 per attempt, or per time to the line, and that's just that's a little bit higher than the 0.96 of the theoretical. All right, let's move on to the next section. Okay, now we're going to complete the table for each player with different percentages: 20, 40, 60, 80, and 100 attempts. And so I've already put in the 60 because that's the same as Nishi. So it's 40, 24, 36 with an expected value of 0.96. Okay, let's look at 20%. So just like here, it's the opposite, right? So 80% or 80 times out of 100, they would score nothing. And then we have to think about what's the expected is 20%. So 80% of that 20% would be 1 time, and 80% of 10 is 8. So 80% of 20 would be 16. And then the opposite would be true for 2 scoring twice. That would be 20% of 20. And again, 20% of 10 is 2, so 20% of 20 would be 4. And when we add that together, 16 plus 8 is 24 points, so the average would be 0.24. Okay, so 40, the opposite would be 60. They're going to 60% of the time miss. Now we need 60% of the 40. So 60% of 10 is 6. So we times that by 4. That would be 24. And then 40% of 40 would be, again, 40% of 10 would be 4. Times 4 would be 16. So 16 times 2, because that's 2 points, it's 32. plus 24 is 56, so 0.56. We got 60, now let's do 80. 80 is going to be the flip of the first one, 20. So this is 20% of the time they miss both. And now we need 80% of 20% of the time. So 20% of 10 is 2. So times 8, that's 16. And then 80% of 80 would be 8 times 8, which is 64. 64 times 2, because it's 2 points, that's 128, plus the 16 is 144, so 1.44. Okay, let's take a look at C. I used the data from above. I've made my graph here. And let's answer some questions about it. 2 asks, how does the mean or average number of points compare for players with 20% free throw percentage, 40, 60, and 80? And the average points per trip increases as the player's average increases, as we can see. Number 3, Nishi's dad makes an average of about 1 point in each 1-and-1 free throw situation. Find his free throw percentage. Okay, so if we look at our graph, 60% matches right up with 1. So we could guess that it would be right around, it's probably right around 60%. And number 4, Nishi's older sister has a 70% free throw percentage. What is her average number of points in a 1-and-1 situation? So 70 would be right about here. We could say that it's about 1.2. Okay, let's check with a area model to be sure. Okay, so here's my area model. We know that 30% of the time they'll have 0 points, and then we have 30% of 70%, which is right here. So 30% of the 70% will be 1 point. So 30% of 10 is 3 times 7 is 21. So this we'll put here 21 points. And then the other section is 70% of 70, which would be 70% of 10 is 7 times 7, which would be 49. Times 2, this would be 98 points. So we add that together, we get 119, so it would be 1.19, which is just about what we saw in the graph. All right, I hope this video was helpful, and I will see you in the next investigation.